Meow.
Hello,
Dog. Meow.
go.
Go dog.
So we want to do this reading of this VCF file, which I have in this data folder. So there's like
Mm-hmm.
a bunch of files, gzip files, non-gzip files, and if we just look at this, there's this package here called VCF Go, which can read this VCF file, which looks like this. But we can write one ourselves if we want. What this code does is it loads in it opens a file with OS, and that's an operating system module that has an open that gives an F and an In terms of the types, it'd be good to be able to just highlight over and see what type that is, but unfortunately, yeah, actually, this is why I want to like. There is a plugin, but it's for VS Code. It's all better, yeah. And unfortunately, like Go2 doesn't work either. Whereas I know it works for VS Code if I load it properly.
we could have VS Code just open and we use it when we want to.
Yeah, just to like check the types and stuff.
Yeah, all the inference makes it a lot harder to see what's what.
I wonder if it's like all the plugins.
Does remind me? Does it have implicit import? Like you import a thing and then all this stuff is just available?
Yeah, when you do this import, it will, when you do go run and build, it will fetch that just like cargo and then put it in that location where your Go path is, and then you get access to all of that stuff. If that makes sense. Is that what you mean by implicit?
No, in terms of when you reference it, it looks like it's explicit. Like to use the things inside OS, you have to say OS dot.
Oh right, yeah. It's like Rust where it takes the last thing here, and if you want to rename it, you can like say like dog, for example, and then it'll become like dog instead of.
Oh, okay.
Yeah,
I didn't know about that.
So if I did that, I should be able to call dog instead of OS.
This sounds better.
And if I do go run dot, yeah, you can see it worked. I just want to see what I have installed. So I have this installed. Yeah, okay. So if I wanted to get the type here, it's loading. Yeah, and then it tells me. Okay, cool. So yeah, we can use this to actually see what the types are, and then we'll use this to actually edit. Yeah, so one problem that this has is that this file can be gzipped or non-gzipped. And so we kind of want to have a way to just read in this
I guess
file.
you can tell by the extension if it's got GZ in it or something.
Yeah.
What's TBI?
Which one?
Some of them have
TBI?
GZ,
Yeah.
TBI.
So that's an index file of this. So this is actually bgzipped, not gzipped.
Yeah.
And you can still read bgzip with like g unzip, so it uses the same like interface, but you can index it with this thing called tabix, which is a bioinformatics thing that lets you access specific locations in the file very quickly. So for example, imagine this is a very big file with lots of rows. So if you wanted to access this specific coordinate, this TBI will allow you to get that, to access that very quickly. Yeah, so let's put that back to OS, and hopefully that won't complain, and it doesn't. So yeah, so if we had something that just checks if it's gzip, so we'll create a function, check is gzipped or something, and then that'll take a file name. So we'll have a file name string and then return bool, and I guess if we go something like VCF file and then slice it from the last two, so we'll go like file name file name, len, file name. So from the second to the end, I guess. And
Yep.
then just check if I don't need that is equal to .gz.
There might be
Yeah, we'll just return that.
extension utilities in OS to like get the file extension.
Oh yeah, we can have a look. So if we just Control Alt D, oh yeah.
Oh, nice. Oh, cool.
So if we
Is
just
there
look at
an
extension,
overview of all the functions here?
yeah, can you just like collapse all of them? Control R, just like in Sublime Text, maybe? No. Yeah, it doesn't have that.
Sad.
Oh, okay. Maybe symbol. Oh yeah.
Oh, yeah. Yeah, that looks. Yeah, there we go.
So we have all these.
Anything to do with extensions?
No.
No. Okay. Well,
That's okay.
I think it is.
So we just return that, and let's
Should that
just.
be -3.
Yeah. Yeah, that's right. Unless I have it like this, but
Probably better to have the dot.
yeah. Or you could split it at the last. Like, is there string things you can do for split? Like, and just get the trailing dot. That would be probably better.
Yeah, I don't know what the string methods are.
There's no way to control D to a string method, unfortunately.
We'd have to look up Go documentation.
Yeah, let's do that.
That's the thing you did before. Is like, how do I get dir?
Yeah.
And we were trying to work that out for Go, and we were really struggling with that.
There was a reflection that we could do.
Yeah, but like, I don't think we worked it out. How to just print the methods.
Split string and Go.
3 ways. Strings dot split. So there's a strings package.
Mm-hmm.
There we go.
After n. So what if we wanted to do like from the right? Is that possible? Split after slices s into all substrings.
Oh, they got example. That's pretty cool to have an example.
You can run it too.
Oh, nice. I remember in that video about Rust you sent me that you can annotate like example usage of an API in its sort of documentation.
Yeah.
And Rust will actually compile and run it.
Yeah.
I wonder if Go has the same thing.
Right.
This feels very similar. It's like writing the documentation. They've got a program that uses it.
I think in Rust they write their tests explicitly in the documentation, so it's embedded as well. Look, let's just try and get it working. So I think let's just keep it for now, and then let's just go like panic here, dog, and then let's just format dot println is gzipped. What the fuck? Oh my god, that's annoying. Oh, whoa, is that annotated?
It populated your parameter list.
Yeah. Oh my god. I'm not sure what's going on.
What's happening?
Okay. Is gzipped. And then how do I just quickly change what I... VCF file. Okay.
Yeah, you have to backspace all that stuff. That's a bit annoying.
Yeah. Unexpected declaration found return. Okay.
What? Oh, you don't. You're missing an open brace.
Oh my god, what's going on? All right. Now, let's run this. Go run. False. Yay.
Good. Yeah.
True. Yay.
Cool.
All right. So, yeah. So if we have this and we have a gzip file, how do we open a gzipped file?
Did you say you were doing that before?
Yeah. So like, I know there's like this compress gzip library, and oh my god. And if we look at the reader example, which takes an IO reader, yeah. So this thing here, this new reader, it actually takes an IO reader.
Hopefully that's a file.
So yeah, so you can see it takes an IO reader, right?
Yeah.
So we need to go from from trying to open this file and then using this gzip library to create an IO reader somehow. So how do we do that?
Well, file might be an IO reader. Is IO reader an interface?
Yeah, it is. Yeah.
Yeah. I reckon file would be an IO reader.
When you
So
say
I reckon file is an IO reader, so you should just be able to pass file into there.
yeah, but like, file has to be treated with the gzip now, since it's compressed with gzip.
Yeah, we're giving it to the gzip reading thing, isn't it?
Yeah, exactly. So we just need to wrap it in a gzip thing if that's the case, right?
Oh wait, you construct an IO reader from F? Oh, it's not a... I'm confused.
Okay.
Does IO reader F do?
So this os.open returns a file, and io.reader is the interface that has a read. Yeah, so it's this reader interface, and io.reader is a method called on it.
Yeah, why is it a function? That doesn't make sense to me. This runs?
Yeah, it does.
What? Is that like a typecast? I don't know.
Oh. So this is
Okay.
an IO func reader. Is there a func reader? No. There's just only a type reader.
I wonder if it's a typecast.
So typecasting to an interface.
Yeah. Like what if you remove the IO reader part and you just say
That's a good
R
point.
equals F?
That's a good point. Yeah.
Like in theory, it should all still just work.
Even though it's taking a IO reader.
Like just make R equals F. Oh yeah, change it there. Because to me this is like.
Yeah, it does work. You're right.
Yeah, this is like upcasting.
Yeah. So it takes an IO reader as the signature, but as long as there's an interface, so we just need to like go from gzip to file. And so if we just look at something that returns file or something, maybe reader.
Sorry, weren't we trying to pass it into the unzipping library?
Yeah, that's right. So this is the gzip unzipping library. and
it takes an IO reader, right?
yeah, that's right.
So file already satisfies that.
Yeah, so if we just put this into here and call compress gzip and this is so annoying. And then there's a method here that says new reader that takes an IO reader, returns a reader. So that's a reader which I can potentially pass in potentially.
Oh, but it's not an IO reader.
Yeah, it takes an IO reader, returns a reader.
What's that interface?
It's got a header.
Whoa, it's a struct. It's not a okay.
So is there anything? So a reader is an IO reader that can be read to retrieve uncompressed data.
Yeah. Okay. See, this I don't like because it needs to be written in English that type reader is an IO reader. Satisfies that interface. It's all implicit.
Yeah. So if we call the method new reader and give it an IO reader,
then the thing we get back we should be able to pass to VCF Go.
Yeah. So if we do new user, and then we just pass it in, and it got rid of this for some reason. Oh, I have to declare it.
Colon equals.
Yeah. And I have to put it back. This is annoying. I wanted to not do that. How do I stop that? Go.
You could probably like just comment out instead of delete.
Run on pose. Static check.
Oh, you're talking about the? No, I think Go doesn't let you. It's just Go.
Yeah, but I want this pack whatever extension that I'm using to not remove it. Oh, it put it up there.
Oh, I see. Okay.
Okay.
Oh, it also has it. Okay, well.
Okay.
Problem solved.
So if you run it now, nice, we got it.
Wait.
So we just need an if statement that's if this is gzipped, and then we give it the VCF file.
There's the magic of interfaces.
So I wonder if we could like declare R and then set R. You know what can you do that?
I reckon.
And then else. And then just do IO reader. I wonder if you could do that. I'm not sure if IO reader returns an error. You need the variable type. So if I did variable type is io.reader. And what's an error type?
Error, like the word.
Error.
Lowercase e.
Oh, okay. Error redeclared. Oh, okay. Let's call it. I'll just reuse that error. Can I just reuse it?
Oh yeah, there you go.
Can I just sign? Oh, so this doesn't actually return an error. Fair enough.
Yeah, that's just that's a typecast.
Yep. Cool.
Does that work?
Yeah. That worked.
Nice.
And then if we do this.
Yeah.
Nice. Awesome. All right.
Yay.
So let's make this into a function that parse VCF. Takes a file name string. And let's just do void at the moment. And then we'll just put in all of this. File name. And let's make this a parse VCF file. Oh. VCF file. File name. Cool. All right. So that's step one. So the thing that we want to test as well is like, how do we get a file handle, and then you have multiple files of these types, VCFs, and then you want to return. Oh well, we need to actually understand this. Are you there, by the way?
Yeah.
Okay.
Yeah. We want to return something from this function.
Yeah. So we want to understand this VCF go thing. Does it give you a file handle that you can just do next on or something? And you can see
looks like you do read on it.
Yeah. So read seems to like give you the next thing. So what if we just return the VR VCF go? So we're going to return whatever that is. So let's just find out what that is by going in here and then looking at this type, which is a reader. Okay, so we just return an IO reader. IO.reader, and then we'll return VR, I guess. And then we should have like a func check, which takes an error.
Yeah, I was thinking about that.
And then just does if does not equal nil, panic error.
Yeah.
And then we can get rid of checker. 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 Cool.
Yeah.
So let's get the two files. Let's get that one, VCF file 1, VCF file 2. I'll just put it in here. VR2, and that will be parse VCF data Intel nomad exome 201.vcf.gz. Okay, does this work? Oh, undeclared. Cannot use VR as type in return statement.
It's not an IO reader.
What is it?
Okay. What is that? Does it say in the error message?
Type VCS Go reader. Fair enough.
And it's a pointer to it as well.
Right, so this won't work.
So you need to say pointer. Yep.
Cool. Nice, we're starting to get to some...
Yep.
Let's just commit this.
Why does it say where do you go?
Because that's the name of my...
That's your Git branch?
Huh?
Is that your Git branch or something?
No, that's the name of my repo.
Ah, okay.
Yeah.
Well.
Alright, so let's have a function that takes...
2 files.
Yeah.
And then...
Oh, let's take a list of...
both of them?
So let's just call this do something, and it will take a list of pointers to these.
Yeah.
So I'll just call this, I don't know, pointers, and it will be of type. All right. So how do I do a slice? It's like
Slice of pointer to VCF.
how do I do a slice of type?
I think you're doing it right.
Right.
Yeah.
Dot reader. And then so we'll call these BCF pointers, and then we'll call this calculate. Okay. So if these are file pointers, let's see if we just can iterate through for what is it? Val
in equals range.
Equals range.
Yeah.
And then we go.
You got to give it the VCF points.
Sorry.
After range, you need to give it the thing you're iterating over.
Oh yeah, right. And then we want to read the thing. So let's just do the what I had, which I can't remember.
It was just not read.
Right. Yeah. Let's see if we can get to the file. If I go here and go control thing, what's going on? It's thinking. Okay, it doesn't do anything.
Try going to your return type.
Yeah. Okay, cool.
There we go. Struct. All right.
So if I do this thing and then do
There's
add.
an IO reader inside it. Is
Interesting.
Yeah.
So it's
As well as a buff IO reader.
VCF error, line number, lazy samples. Interesting. So.
But R is private because it's lowercase.
Yeah.
So you just get header and line number.
So if I did like at read, reader.read, and it returns a pointed variant.
Okay.
So if we go format.println val dot, I guess we'll call this row or variant. No, this is not variant. This is just a
That's a VR.
yeah. And then we need to do vr dot read. And then we should get the first thing or some of them. So if we do now go calculate, and then how do I make a slice of these? Can I just do this?
Good question.
No.
I think you use curly braces, maybe. I'm not actually sure.
Yeah, curly brace, and I have the type and how many. So if I did Does this work? Didn't complain. Well. How come it didn't show me the error?
Undefined VR. Do
So
you need the colon equals, maybe? Must be colon equals.
User not in selector.
Use of... Right. So that's not the type. The type is BCF Go Reader.
Ah, yeah, that's true. Well.
What?
Cannot use literal type as type. Okay.
Why not? Why not?
Let's just create it. Var slice.
Oh, what if you don't put the size in there?
Oh yeah. Nice.
Question: can you also remove pointer VCF reader? Like, it should be able to infer that.
That would be good.
No. Okay. You need to say the type.
That sucks.
That sucks. That's pretty lame.
What if you did like list and then infer it?
How do you make lists? It's the same problem.
Expected type. Fair enough. Okay.
Bad.
So explicit. Calculate list.
It's like the opposite of Rust, where like Rust will
Yeah.
implicitly infer things like at a distance. You know, based on how you use it, it'll infer stuff. And this is the opposite. It's like it infers a teeny bit.
Yeah.
Nothing.
All right. So we have our variant, and we kind of want to create a way to compare two lines. So like, given the list, we want to like if I just write a comment here. So we have these things, and we still don't know the API for this vr.read, what you get back. So we should.
That's the variant.
Yeah, that's the variant, and it should give, like, we need to access these things. So what do we have? We have Chrome, so, and then a position, and then like a letter and another letter potentially. And that will be the signature for where it's at. And so if you get something like 1, and then the other one is like chromosome 2.
I'm seeing 3 things before you get letters.
Yeah.
Like in the highlighted bit, there's 2, 1, and then there's a number, and then there's RS.
Yeah.
Like what is
the RS is an identifier which you can use as well. Yeah. So that can also be part of it.
Okay.
Yeah. So we could have like an RS 123, and this could be like RS 324, 234. So one way that we could do this is to, just have some function that just returns the minimum between these two. And then if it, so this
position.
Sorry?
Minimum position?
Yeah, the minimum position that comes from these two files. So if there's another one like F3, which I can't.
Are we doing merge?
Yeah, we're going to merge it, yes.
No, like a merge sort merge.
Yeah.
Cool.
So if it's like, let's make this 10, make this 5. The 10 should be here. So it assumes they're sorted as well, which which is fun.
We can put assertions in for that.
Yeah.
Like as we read the next thing, we can go like make sure it's bigger.
Yep. So the minimum one is file 1, and we can start to do this thing where we grab the minimum value and then we check. We want to find equalities. So
we want to merge things at the equal position.
Exactly. So when it gets to the point where
Yeah. So that's we'll need to define like addition of two variants
yes.
or like merge of two variants.
Yeah, so let's just put that case in. So let's just say that this file 1 has this one and file 2 has this one as well. So this is where we do the merge, and that will do some funky calculation based on these things inside here. And then, yeah, so if the next min is like F2 because the next thing and then let's say it merges with this guy, you know, so this would be like 20, and then this file has that, so it's going to do the merge. And then,
so what would merge do?
The merge will look at the the values in here, and then based on the values. Oh, so the other thing is these files might have different. So we need to know what the files are. So this could be the exome, and this could be the genome, and they might have different different things potentially. We need to know what these are as well. So there's a label that needs to be followed through. So when
does it make sense to add them together if they're like?
Yeah, that's what this person requires to do some.
Okay.
Yeah. In fact, in the requirements is actually simpler in that we won't have 3 files. It'll just be these 2 files that we're doing the merge on.
Yep.
Yeah.
Our algorithm, like once we have a merge, like they should all extend to any number of files.
The problem there is that because the person's calculation is very explicit based on when it's this thing and this thing, do something special for this one and do something special for this other one. So the custom logic is going to be very tailored.
Okay.
Yeah.
So it doesn't extend.
Yeah, it's not very general. It's very very tailored. Yeah. So in fact, this can be like an array because we know exactly how big it's going to be.
Yeah. Okay.
So do I just do that?
Yeah. Or possibly just make it 2 parameters.
Yeah, that's true.
Because if there's custom logic for one or the other, then, yeah, we might want to know which one's which.
Yeah. Okay, so that makes it a lot simpler actually. So
yeah.
So we need to extract this information. So let's just go ahead and read the first thing. So we'll just go v is equal to exome dot read, and then we'll just panic dog, and let's just print this again. Make sure this was working. I don't know. Oh yes, okay. VR1. Actually, I'll call this genome. Is there named arguments? There isn't.
That's a great question.
No. No.
There is not.
Lame. Named arguments are the best.
Python's argument parsing is like the best ever.
Yeah. I agree. Okay, interesting. So it just panicked and dog, yeah. Okay, cool. So we want to look at the API that this variant thing gives us. So if we go in variant, it's a struct, and it has a ID, pos. These are all public, so we can grab those.
Yeah,
And
that's
maybe
good. That's simple.
I mean, we could just make a struct that has just those and like make this thing like have comparison. So we could just be like variant subvariant. I'll just be like variant, I don't know, ID or something, or variant unique, variant info. Or I mean, maybe it's not worth.
What's the substruct for? I'm not actually sure.
So I want to do a comparison on these 4 things, right? Or
yeah.
Even these things potentially.
Yeah, I just write a function that takes 2 of them, 2 variants, and checks on.
Yeah, that's true actually. So we'll just do like a func variant comp. Can we overload? Can we overload operators?
I don't think so.
Go overload operator overloading. Does not support. Damn it. All right. So we'll just create a min for 2 variants. What happens if I call it min? Vmin. We'll call it vmin. Fix a variant pointer. And so we saw that variant had these things. So the first thing we can check out so I kind of like what the sort of dumbness in me wants to just go through the tree of values and sort of like first say like which one is smaller. So we'll just say like v1 min is a v1 smaller, and then we'll just set that to be false or true or whatever, and then go through the tree of stuff, and then and then sort of set that value based on the so what do you reckon is a better way to do this instead of
you need to define what the ordering is.
Yeah, so the first ordering is by chromosome, right? So if the chromosome, how do I access something in
let's actually write out examples of one that's smaller than the other, and like just dig into why one is smaller than the other.
Okay. So in this example, so if you have in the first tree is like chromosome, in the first tree it's like chromosome 1 versus chromosome 2, right? So you would say like this one's smaller, and you would immediately return based on this.
When you say tree, is it more like a list? Like you first check chromosome, and if they're different, then you can stop there.
Yeah, exactly. That's what I mean. Yeah. So
yeah,
like
yeah.
So that's
I think that's just going to be like a return statement.
Yeah. Okay. So how do I access something in the struct?
Dot.
Okay. So v1 dot chromosome is smaller than v2 dot chromosome. And this is going to say which. So it'd be nice to say return like 0, 1, or -1. Where, how do I do like docstring?
Wait, this says min, so it's like you should be returning one of them.
So this is gonna be, huh? No, I take that back. I don't want to call this min. I want to like have this return like -1, 0, or 1.
Okay.
Yeah. So this function should be called something different, like v compare, and return that where if v1 is smaller, return -1, if equal, return 0. Yeah. So yeah, so it's pretty easy to know. Wait, else if. How do you do else if? Is that how you do it?
Hopefully. Yeah.
So this is where they're equal, and then we want to check the next thing, position. Yeah, so if they're equal, then we want to check position. So we'll go if. You know what would be nice? If you write a function when you just give it, it's like recursive. So I don't have to keep writing these branches. That's why I look at it as a tree, but I mean,
yeah, the difficulty is that they're all different types.
yeah, the reason why I don't use ID is because you can't really do this equality thing on ID. Yeah. In fact, it's really these three that tell you the order. I'm guessing that the other things are not going to be impacted, actually. So when they're equal, which is this case, I'm just going to return 0 here. And then if we somehow get out here, we can panic. Something went wrong.
Is the chromosome is a string. What was position?
Position is this value.
Is what type is it?
uint 64. What's the problem?
I wonder if strings has a compare function.
Right. So you reckon this might not work?
Yeah, I'm not sure about that. I don't know. I mean, we should just run it, see what happens.
All right, we need. Hey, I'll be right back. I just got to check on my my food. Just give me a sec.
Yeah, no worries.
Hello.
Candles can go out, but they can't go in.
Sorry?
Candles go out, but they don't go in. Why?
What candles?
Candles, any candle. When a candle goes out, that's a thing that exists. But candles going in doesn't exist.
It goes into a cake, right?
Yeah, okay. Yeah, true.
Okay.
I have no idea what the int types of Go are.
Yeah.
There's so many different language approaches.
I'm pretty
to it.
sure it's like Rust that has like the different types of precision.
Oh no, we saw it just before. We saw uint 64. So it's like return int 8, boom, whatever.
And you can't have this panic here, right? Or can you?
It should be right.
Undefined variant 43. Oh. VCF go dot variant.
Yeah. Is there like a using? You don't have to go everything. No position. Oh, it's pause.
Is it?
Yeah.
Is it?
Go to the strap.
Oh yeah. Oh yeah.
Pause.
Ba-ba-ba-da, ba-da. Ba-ba-da-ba-da-ba-da-ba-ba. Ba-ba-ba-da, ba-da. And does this work? True. It worked.
Oh, cool. Okay, so you can do comparison on things.
Yeah.
Mm-hmm.
So we can get like unreachable. Lol.
Oh yeah, we should just delete that because it's literally unreachable.
Yeah. Yeah, so we can get a comparison which gives us the thing to do. So we can go comp is equal to v comparison compare, and then we'll compare the variant. So we'll have to get the variant. So yeah, so we kind of like want a while true or something. And how do you exhaust? So we want to like read both of these at the same time. So maybe
let's just make an infinite loop that reads, and we'll see what happens if you read too far.
So how do you do infinite loops again? Loop? No, for.
No. Oh yeah, no, you're right. For loop is rough.
And then you just do like v. I'll just print line. Print line. Exome dot read.
See what happens when we hit the end.
Genome dot read. I'm eating soup.
Yeah, good. How big are these files?
Oh, they're pretty small.
It's still going. What is it?
That's not good.
Is it looping?
I hope not.
Like, should it have finished by now?
Yeah.
Okay.
I think it is looping.
Yeah.
So
maybe when it gets to the end, it's just printing the same thing.
Wait. Chromosome 1, 1348.
Yeah.
Chromosome 1, 1348. 1348.
You're printing 2, remember?
That's true, yeah.
The last 4.
So it's just printing those 2 again and again. Oh no, wait. 82? 80?
Maybe it's just slow.
Maybe I'll just do one of them.
Just print the position.
Yeah, that's a good idea. Oh yeah.
Read pause. That should be faster.
Oh, there we go.
No, okay. So it really was though. I guess it's just trying to output all that content.
Yeah, there's a lot of content in that.
Mm.
Nice.
And it's all going through VS Code, just like rendering paths.
Yeah.
Slow it down.
So, so we have this thing that can execute. How do we deal with like terminating at the end? What do you have to do?
So there must be some way, like what's on reader. There must be a method of if you're at the end.
Also, before we even do that, when we open this file, should we do this? Defer f.close?
Oh yeah, we should. Lol. But no, defer will run that at the end of the function.
That's not good.
That's not good.
So how do I defer to close later?
This is where like the destructor would be nice because you could return a thing and in its destructor it would close. But no, can't do that.
So you would have to open it in main.
You'd have to like return F, and then your caller would have to call close if it wanted to.
Yeah, because these are technically open, and if the program breaks, it's still technically open, right?
I think it might depend on the operating system. I think Windows is probably more flaky than others, but like I think at least on Linux, if the process dies, the file handles it has open should close. I could be wrong.
Right. It's still pretty bad.
Like we haven't been closing it at all, and you haven't been having any trouble with reading it again.
That's true.
It's probably fine.
Okay.
But like, yeah, in general, if you want to have something closed when you're done with it,
you'd probably
like,
just like return this. So what we could do
Mm.
is return a tuple, like multiple things, and you return f as
Yeah.
well. And then,
whatever F is,
well, that's a file.
file.
Yeah. So
Okay.
then you could do in here genome and f1,
Mm.
f2, and then you just go
And
defer.
defer. Yeah.
Let's just have that there.
Yeah.
Oh no.
Oh man, that's not too pretty, is it? I guess Python has the same problem. Like Python has with, but if you want that to finish in an outer thing, not in a function, it doesn't happen.
So if I want to return multiple, do I just put comma and then just return multiple?
Yeah. Oh, it needs to be in brackets. It needs to be in brackets. Definition.
Like this?
Yep.
Right.
There we go. Wait, what? Oh yeah, it needs to be the right type.
Why? Is it file pointer?
We'll find out. Make it like int 8, and this should tell you what it actually is.
I'll make it string. This is not very helpful.
Go to the return.
There we go. OS.
Point it to O file.
And then run. Yay!
So, given that it's panicking on a nil, maybe read will just return nil when it's done.
Yeah, so at the end of the reads, we just need to check that if they're if they're both nil, right?
Yeah. Well, not both. Like one
Yeah.
can finish before the other.
That's true. So if one of them is nil, you finish that one, and you don't want to. So it's really, you don't want to print this.
I remember when implementing merge, is like you have your main loop which is checking both of them, but the moment either one becomes nil, you break out, and then you have a loop that exhausts one of them, and then a loop that exhausts the other. So it's like 3 loops.
Oh, okay. Cannot convert exome equals nil.
It's not exome that will be nil. It'll be
It's the read.
The read.
I see. Right. So if we store the variant, so the exome variant to be a exome.read. Genome.read. Yeah, so what were we saying? Like if they're both nil, we want to break.
If either one is nil.
If either one is nil, we break?
You break, and then you have 2 loops, one for each, that just keeps reading until it's nil.
So this isn't just an initial... So this is really just the initial thing. So I don't actually need this
The
for...
first loop is when they both have content. The
Yeah,
moment
okay.
one doesn't have content, then you're just appending the rest of it in.
Yeah,
You
so
have no comparisons to be done.
So we do want to break from this.
Yeah.
But we also want to do another for loop.
Yeah. So you just do it on both of them to make sure no matter which one goes nil, you've read the other one.
So don't do this, are you saying?
So you want that to be an OR, because it's either one going nil.
Yeah, but if it's OR, right?
Yeah.
You might still have stuff in the other one.
That's what the other 2 loops are for. It's for the remaining stuff.
So you have to say which one is remaining.
So that's why there's 2 loops. You just exhaust each one in turn.
Okay.
Yeah, it is implicitly checked.
Yeah. But you still need to identify which one's not exhausted, right?
If you do both of them, then it doesn't matter.
Right. Okay. So when you say do both of them, though, what do you mean? How do I do that?
Both exome and genome have them as separate loops.
Oh, okay. Right. And then I want to go... can I just... Wait, what am I doing? Another for loop.
Yeah, infinite loop. Yeah. And then we break out of that when that's nil. Yeah. And that way, no matter which one goes nil, we've read the rest of the other one.
I guess why it was confusing is like, what are you going to do in this then?
What do you mean?
So in this case, right?
Yeah.
In this case, you're going to do calculate.
Yeah.
You're going to do some calculation based on the values that are there. And then these are just to append at the end, right?
Yeah, they'll never match position because the other one's empty.
Yeah. So in here, you want to do the v compare. So if you do the comp equals this, and then we give it exome genome. Can we do switch? Is a switch?
I think so.
Nintendo Switch.
No.
Switch I, case blah blah blah. There's no breaks. Okay.
Mhm.
Comp case 0, case -1, case 0, case 1. Alright, so if this is less, then we want to do, we just want to add that. So we need to,
yeah,
we'll just, we'll have this function that adds,
yeah.
and-
Where are they all going? What's the output?
so we have to create a new one of these. So we have to write it out, but for now, we won't write it out. We'll just print.
I think for now we can return a list of variants, and so this thing can just be appending to a list of variants, and at the end it just returns it.
Why do you want to? Oh, so you mean like just make it grow and have a slice of variance. Okay, so we'll just have a variance is equal to,
and that'll be our merge result. Mm-hmm.
Oops. Yeah, so if this is the case, we want to, we know that's the smaller one, and because it's the smaller one on the left, we want to keep iterating through those and keep reading. So at the moment, what this will, like, if we have, so I'm thinking, like, can we like go back to this loop and only increment this read based on something like a flag?
So yeah, this read, the fact that it's mutating is making things a little more difficult. We want to be able to read the current line without incrementing.
Yeah. So how do we like read without incrementing?
So I feel like we need to make a wrapper so that something that stores the last read, and yeah.
I want to know how it does do that though. Like, what does this read function do? So if we go to the reader, so this takes the reader VR, it calls read bytes, which gets the line. Okay, so it reads a line which goes up to the new line from its buff.io thing. And so by doing that, it's already gone past that line, right? You don't get that back once you've done that read bytes.
Yeah, read is mutating.
Yeah.
We want a non-mutating read.
And then you've got like all the fields that go into that struct after it's parsed. So yeah. So if we have something that just reads but doesn't mutate, as you said, then that way we can read the thing
and compare them, and then choose which one to increment. Which one we put into the result.
So should we do like a struct some dog struct?
Yeah.
So that's gonna be the variant.
So I feel like we'll have the VCF reader and the variants, the last red thing.
Last red.
Yeah.
Last variant. And reader. And these are pointers.
Mm-hmm.
So if you create this thing, how do you create a struct again?
I think you say dog and then curly brace.
Right. And then you just you can't specify the names, can you?
Good question.
Let's look at the struct documentation.
Construct, create. Yeah.
Name. Oh yeah, you can.
Well, you can. Cool.
So we want
Name,
last variant to
struct,
be exome.
dot read. And then the reader to be the exome. Yay. Cool. Nice. Genome dog. Dog genome. Give me dog genome.
Okay. So
Probably want this outside of the loop.
we should probably call it something else.
This is why I called it dog.
Yeah, I know.
So how do you call it?
It's like some container of the read.
It's almost like a buff IO, but
Yeah.
it's like buffers one value.
We'll call it like a buff variant buff.
Okay.
Because it is storing the variant.
Buffiant.
Buffiant. Oh yeah.
Buffiant, the genome slayer.
Exome buff.
I hope this becomes a real project with the name Buffiant in it, and someone comes to read it one day.
What the hell?
and hopefully they just work it out and go like Buffett there.
When we want to do the comparison on inside the last variant, right?
Yeah.
And so if we did,
Yeah, the reading last variant is our non-mutating read.
yeah. So we do muff dot last variant. And then based on that compare. Oh.
We should be, that nil check should be happening at the top of the loop.
Oh yeah. That's a good point. I'm just gonna call it V. This is too hard to write.
I agreed. I mean, it doesn't even need to be capital either.
Oh really?
Focus.
Yeah, because it's not public, right?
It's just for your module.
Right. Yeah, it's not public in the, yeah. Exome buff, and then we just, yeah.
Yeah.
Exome buff dot v. Why is it saying this?
You gotta rename the fields.
Oh, yeah, that's true. Okay. Still saying that? What does that even mean?
What's happening? Why is it coming and going?
Okay, vet missing a semicolon, comma before new line in composite literal.
Is it?
Is it because you can't do it like that? How did they do it? You can't put in new lines, maybe? That would be really bad. Huh.
Is that actually it?
I think it is.
Okay, so Go has semicolons, but the style guide thing is to not use semicolons, and they get just like JavaScript, they get sort of there's a rule on where they're put in automatically, and so that format must be triggering the rule, and I reckon it's putting in a semicolon. That's my guess. Which is really dumb. I hate that rule of automatic semicolon insertion.
Why is it saying that?
Type.
Sorry?
What is genome?
I thought that was this V. It's VCF Go variant, right?
What is genome?
Oh, right. VCF Go reader.
Yeah. It does not have a V. Line 100.
Oh, sorry. Yeah, you're right. Yeah, thanks.
Yeah.
Yeah, so if this is the case, we can just add it to our thing. b.push exome buff.b.
If only it were that simple.
So that one's smaller. And
as in, if only you could just do .push.
No, I understand, yeah.
Yeah.
But we want to like push it in, and then we want to increment the next one and do the compare again. So we want to then do this compare, so we have to increment this guy. So we go exome buff dot v is equal to exome buff dot r dot read. If it's equal, we'll just push them both in.
This is a proper merge. Look at that. We can actually create a method on that struct.
Yeah, that's what I was thinking. Instead of like
call it increment.
Yeah. So how do we create a method? We just do
func, and then in brackets like
Buffian?
Buffian, I think.
Increment?
Yeah.
Or we'll call it inc. So we go. Oh, how do I do like self and stuff?
Oh, you give Buffian a name.
Okay. B.
Yep.
And then. So
now we're writing C code. B.v equals B.l read.
Right.
I'm gutted.
Yeah. It's pretty disgusting.
What are we doing? What are we doing?
Oh, wait.
Oh, actually, no, that's a good point. And it can return the old value.
Yeah.
Yeah. You gotta store it.
Yeah. So
yeah, that's fun. Yeah, very.
Does it mutate? Do I need to do a copy though?
No, it's pointless. You good? Yeah, it's just updating pointers.
So I'm saying this is a pointer to the original b.v do a read and modify this.
You're modifying the pointer, not the variant.
Yeah, no, I know. Like, but if this is a pointer to b.v, and then this sets the new pointer for b.v to this.
It's not a pointer to b.v. It's a pointer to b.v's variant. Like b.v is already a pointer.
Yeah, sorry, I kind of meant that. Yeah, you're right. Yeah. What yep. So get rid of this. Yep.
That's kind of neat.
Yeah. All right. Will this work? I already there's no method push.
Yeah, there's the
How do I? Is it add?
nah, it's just you remember append?
Yeah.
You gotta look up the append function, how to use it. It's like v equals append v item.
Oh, really?
Yeah,
Lame.
it's lame.
Append. Yeah, you're right. Value of type is not used.
It's not what? Oh yeah, you gotta use you gotta set v equals that.
Oh. Okay. What is that doing though?
So think of v as a pointer
Yep.
to the array in memory.
Yep.
When you append to an array,
Mhm.
you increase the size, and that may force it to reallocate somewhere else. And so that means the pointer to the memory will need to point to that new memory.
But it's not creating a new slice every single time. It is appending it.
Could create a new slice.
I see. Depending on the capacity.
Yeah, once it hits capacity, it reallocates, and that's a new slice.
Okay. 93. Oh yeah, let's get rid of that.
It's really gross that you have to deal with that kind of implementation detail of lists, like in basic append to list.
So for this one, if we have broken from this, we want to just keep incrementing our exome buff and appending to it.
And that's actually our for loop condition. Sorry, this is our for loop condition in all of them. Yeah, they're not infinite for loops. We just use that as a condition.
Yeah, exactly. So I'm just doing. Can I put it in here? The read. So I go like increment. Can you? No, you can't do that. You probably can't. Yeah, you probably can't do that.
You don't want to be incrementing it condition because of checking for nil.
True. Oops. All right. See if this worked.
Return v.
Cannot return. Oh, oops. No result. Values expected. Okay. What's going on? Why is it just hanging?
Infinite loop. Alright, add print statement.
Nah. So are we in here? Are we in here?
What's your Steam? Oh, wait. Yeah, never mind.
Dog.
Who's dog? Where are we? Hmm. Do we
So-
ever get a different case? Because that's a default to the Switch. Like panic in it.
Oops. Is it just default?
Should be. Maybe it's just slow. Let's print out the values of the yeah.
Yeah. We could do that.
To
Let's just see which one.
see if it's changing.
I mean, oh, sorry, it's panicking.
Yeah.
Nope.
Year 2. What's year 2?
Here two means that they're equal.
Ah.
So
That seems wrong. Well, I mean, it could be right. Maybe they've got the exact same set of things.
panic. And then let's just print line of X up. Oh, we should print the. Yeah, we should have like a. We should just make a 2-string for this thing that we have.
Let's just print the position of one of them and just see if that's incrementing.
Yeah, sure. Let's just see what these positions are first.
Yeah, if it's incrementing, then it's working as normal.
Yeah, why are they the same?
Panic dog.
Why would they be the same? Do they actually have the same position for the first one? Let me just double check that.
Just run it. See it all.
True.
Oh no. Yeah, it's not moving. Okay. Is that increment wrong? I know. We need to take a pointer to Buffy and
Okay.
make a copy, and then we're mutating a copy.
Oh, wow.
That's why.
So this should be a pointer.
Yeah. Yeah. We were reading, but we weren't updating the
So is it enough to just set this to a pointer, or do I need to also?
Yeah, that's enough.
Right.
I think we'll find out.
Yeah. Wow, that's really That's a really bad bug to have. Like if you didn't know, if
There's
you
the copy. Yeah.
like if you want to write self methods and you want to mutate on self.
Mm. The fact that you can write methods that do copies, even though it looks like you're doing it on the thing,
Yeah.
like that doesn't happen in C++. You can't write a method that causes you to copy yourself before you call the method.
I see. Cool. Well, let's like have a look at our V.
Yeah. Print the length.
Yeah.
Or whatever, yeah.
$84.
That is not a big number. You're
Yeah,
right.
there's not many.
I can't believe I had so much trouble just printing them out.
Oh, there's a lot of like metadata in there.
Okay.
But it'd be good to where it prints the position, also print which file it's from.
I would love to see those break statements turned into the for loop conditions.
Oh yeah.
Because these are actually while loops.
Right. So like that.
You need to negate it now.
Yeah.
Which is to continue rather than break.
Do I have to do this?
Yeah, you could do that, or you could do the De Morgan. Morgan.
So you just negate both of them and then change this to an and.
Yeah.
And I need this to be... that is a useful thing.
De Morgan. And no brackets.
Yeah.
No brackets?
Oh yeah. Sorry. So if it does not equal nil... yeah, that looks a lot neater.
I do like the practice of using infinite for loops. And I guess it just, if it happens to have that pattern, then you may as well turn it into regular.
Right.
But like starting off with infinite, I think is a nice nice way to think.
No, this is good. This is good. Let's commit. Switch make to VCF file, calculate based on comparison of stuff.
We wrote a merge, yay, merge. So that wrapper thing, that was actually pretty lightweight amount of code to do. I'm pleased with that.
Yeah. I mean, the tricky thing was that thing. Yeah, the copy. But the wrapper was pretty easy to do.
Like this is literally the first time we've written the method, so yeah, that's just general method.
That's true, yeah. And just knowing that. But I guess you always want to pass a pointer to the struct when you write these things.
I think generally, yeah. Like unless you're writing it for like an int or something.
Yeah.
Or even that, maybe if you want to do any mutation, you need a pointer. Otherwise, you don't.